Hello, welcome to all. Okay, today let us study about the Clausius-Clayperon equation of the thermodynamics. Okay, we may derive this equation by making use of the Maxwell's thermodynamical relations. See here, just let us start with the Clausius-Clayperon equation and let us see the very interesting applications of this Clausius-Clayperon equation. See here, this equation, which can be easily derived by using the Maxwell's thermodynamical relations, is dP by dt is equal to L by T delta V, V2 minus V1. See, these are all of you know that what is P and what is T. P is the pressure and T is the change in the pressure with respect to the temperature can be given as the ratio in between the latent heat of the system here and the product of temperature and change in its volume. And okay, to see the change in pressure, suppose that now you are on a ground, see at the sea level, you may go to the top of the hills, then what happens? Obviously you will see the change in the pressure. Okay, see how do you see the change in the volume? It refers to the system under consideration. Okay, suppose that you are taking some, see here I am considering a system of water. Okay, I am taking some water in a vessel. Okay, you are supplying some heat to the system. Then what happens? See here you are performing this heating at one constant pressure. Okay, at P at the sea level, otherwise sea level. Okay, on the ground you are doing this, you are performing this thermodynamical process of heating in the water or in a liquid. Specifically, you may take this as a water. Let us consider this as a water. What happens as you go on heating? What happens as you go on heating? Generally, in case of water, what happens as you go on heating? Okay, this water transforms into the vapor. Okay, then what happens? This entire vapor is filled in this vessel. So now the volume of the system is changing. Volume of the system is changing. Okay, so as you increase, as you supply the heat to the system, as you pump the heat into the water, what happens? Water boils and it transforms into the vapor. So if your piston is actually here at the water level, as you go on heating, what happens is, okay, the vapor, it transforms into the vapor and that vapor pushes this piston. Okay, so here you will see the larger volume inside of this vessel now. Okay, this entire volume is occupied by enlarging the vessel by the water. So here you are going to observe the rise in the temperature. Okay, suppose up to this point, if this is V1, volume of the vessel up to this level, V1, now it is changed to V2, okay, which is always greater than the V1, if it is water. So volume of the system is increasing. Volume of the system is increasing here. Now, what happens to this V2 minus V1? What happens to this V2 minus V1 here? Now, V2 minus V1 becomes positive as V2 is greater than V1. V2 is greater than V1. Okay, so you are always going to end up with a positive value. So, this entire thing, this RHS is becoming positive. Okay, this entire thing is becoming positive. So, as, see what you will see here is, as entire thing becomes positive, this LHS is also positive. Here dP will be proportional to dt. Okay, as the pressure increases, then the temperature also increases. Okay, see here at the top of the hill, where you see P is equal to P, let us say hill. Okay, so here there also at the top of the hills also you are going to perform the same experiment. What happens there also? What happens? Volume of the water increases. Volume of the water increases. Okay, this will be positive. So again you will see the dP minus dP is proportional to dt. Okay, here as the pressure increases, what happens? Temperature also increases. Yeah, see, you take this these two pressures, where do you find the more pressure? At the sea level or on the top of the hill? See, the pressure, atmospheric pressure is always high at the sea level. Why? Because there is a very thick blanket over the Earth's surface. As you move up, the width of this blanket decreases, so the pressure at that particular point decreases. So what is happening as you're moving from sea level? As you're moving from sea level to top of the hill, what is happening? See, pressure at this point is P sea level. What is this P sea level? This is the pressure at the hill. As you move up from the ground to the top of the hill, what is happening? Whether the pressure is increasing or decreasing. The pressure is decreasing. As you move up, pressure is decreasing. Okay. Here P hill is less than P sea level. See what happens as the pressure decreases now. dt also. Here what you are doing, you are trying to boil the water. Here this T refers to the boiling point. So what you can conclude here is, as you are going from ground to the top of the hill, what is happening to this T? What is happening to this T? This depends on what is happening to the P. What is happening to the P? P is decreasing. So what happens? P also decreases. What is T here? Boiling point. So what is the meaning of this? As you go to the top of the hills, water starts boiling at the lower temperature. This is one of the important things which can be explained by using the Clausius-Clayperon equation. As you move up, pressure is decreasing. Okay, as you move up, this is a minus pressure. That means decrease in the pressure. So you will see the decrease in the pressure. Okay, this direction is a negative pressure direction. So what happens? As you move up, you always see the decrease in the boiling point. As you move from Earth to or sea level to Earth surface to top of the hill, what is happening? Boiling point. This is a decrease of the boiling point direction. Boiling point is decreasing. What are the consequences of this? What happens when the boiling point of the water decreases? That means water starts boiling at a temperature lower than that on the Earth. So what are the consequences of this? So we may simply explain this consequence in a single statement. see, cooking the potatoes on the hills is difficult than cooking the same potatoes on the earth. Why? Here you may apply this by changing the boiling point concept. On the earth, so water boils at some higher temperature. So you may safely cook the potatoes until they are cooked. If you go up with the same vessel and same water and same potatoes, what happens is, at the top of the hills, water starts boiling at a lower temperature. So immediately, see, you are left with very few water in the vessel, okay, even though potatoes are uncooked. So, in order to cook the potatoes fully, you have to pour more water, more and more water. That's why, okay, cooking anything on the hills is different compared to the cooking at the sea level or at the ground surface. So, this can be explained by using this Clausius-Clayperon equation. Okay. We may also explain another important called regalation. I think all of you know this. This can be explained by using the same Clapeyron equation. Okay, now let us discuss about this. Let's try to explain this by making use of the same Clausius-Clayperon equation. So here, what is your system now? Now, I am taking some ice cube, okay, in this vessel. Now, this vessel is totally filled with ice. Yeah, up to this point. Now, what is this? This is ice. Ice. See, now up to this level, up to the piston, you are having the ice. Now what you are doing? Now you are supplying the heat to this system. Okay, water in the form of ice. Now it is in the form of the ice. Now, as you go on heating, what happens? It melts. It melts. At what temperature? At the melting point. Now we want to see the change in this melting point with respect to the change in the pressure. So to see this, you may immediately go for this Clausius-Clayperon equation. Clausius-Clayperon equation. Okay. Now, what happens to the ice with a change in the pressure? With a change in the pressure. Okay. Now you need not to go to the top of the mountain, because you may artificially increase or decrease the pressure on the system. That means this ice. Okay. Now, because our aim is to explain the regalation process. Okay, here, now see, at the normal pressure, you are supplying the heat to the system. At the melting point of the ice starts melting, and this ice transforms into the water. Then what happens to its volume? Now the initial volume is V1. Whenever the ice melts completely, its volume decreases. I think every one of you know this. Only up to this level you will see the water. So what is happening here? The volume of the ice is decreasing upon melting. Okay, the reverse thing is happening here compared to our previous case. Here, now it's your final volume is this much only. Now what happens to your dV or the pressure difference V2 minus V1? See, since V2 is now less than, now V2 is less than V1, what is happening? V1 is now negative. This is negative. So, this entire thing, RHS becomes negative, so LHS is also negative. So, dP by dt is equal to negative. What is the meaning of this? Exactly the opposite thing happens here. What happens here? See, as the pressure increases, the temperature decreases. Here, what is the meaning of this temperature? Temperature refers to the melting point of the ice. Melting point of the ice. So, the reverse thing happens here. What is that? As the pressure increases, temperature decreases. But what is temperature here in this particular case? It is the melting point. So, what is the consequence of this Clausius-Clayperon equation? As you apply some pressure, as you increase the pressure on this system, that means on the ice cube, and go on applying the heat, then what happens? As the pressure increases, melting point decreases. That means you need not to heat for a long. Just after some time, the ice cube starts melting. Okay, immediately it starts melting. Why? Because its melting point is decreasing due to the excess pressure. If you push this piston downwards, what is happening? The pressure is increasing. So now you need not to supply more heat in order to convert it into the water. It starts melting at some lower temperature point. That means as the pressure increases, its melting point decreases. What are the consequences of this in our daily life? That may be explained by considering the regalation process. I think all of you know this. Regalation process. Now what is this process? That means here in this process you may club the two individual to separate ice cubes into one ice space. How is this possible here? We call this as a regalation process. Here take a block, ice block A, take some ice block B, A and B. Okay, now, anyway, these are exposed to the environment or sunlight, some temperature is passing into this system. Why? Because the temperature of the system is more, temperature of the surroundings is more than the system. So the direction of the heat flow will be like this. So some heat always flows into the system and the ice starts melting at the normal temperature and pressure. See, now you need not wait for a long for this melting. If you apply some pressure from the top with one piston and push these two blocks down, okay, then what happens is immediately you will see the melting of the ice. That means here you see the water layer, here also you will see the water layer. Okay, here the ice at the edge starts melting. But here what you have to do now is, as you immediately, suppose that the temperature is the same here now, but as you immediately lift off the pressure, you remove the pressure, then what happens? Whenever you apply the pressure, its melting point decreases. Okay, that's why it is melting. Actually, it is not its melting point. Whenever you lift the pressure, what is happening is, again its melting point is restored. That means, actually it has to melt at somewhat higher temperature. Okay, but it is started melting due to the pressure. Whenever you remove the pressure, what happens is, again, this water layer solidifies. Why? Because it is not the natural melting temperature of the ice. Okay. Why? Because again the melting point of the ice is increased. So it waits up to that temperature in order to melt. Okay. That's why the solidification of this already melted ice, that means that water, takes place. Then what you will see here is this clubbing of these two ice cubes takes place. Okay. At least you will see them together for some time. Okay. This process is called as the regalation process. So you may explain this clubbing of the two ice cubes into a single ice piece. That is a regalation by using the Clausius-Clayperon equation. Well, let us see how it is possible. Okay. Now I am going to take two ice pieces. You see, these are the two ice pieces. Now, whenever you just put these two ice pieces like this and apply some pressure on this for some time, and and remove the pressure. Okay, then what is happening is you will see both of them are clubbed together. Both of them are clubbed together. This is called the regalation process. You may explain this regalation process with the help of this Clausius-Clayperon equation. Okay, let us stop with this.